All right, this is physics, and we are going to be continuing to work out of chapter 22. And this is the end of section 22.1. And it is a brief introduction to circuits. When we start working with electricity, most of what we're going to do will have to do with an electrical circuit. And it's a shame we won't be in class because you don't actually get to work with them. But if we were there, we'd have batteries and light bulbs and switches and all the rest, and we would have spent some time building some things. If we come back, we may do that because those are nice labs to do. Before we start this, though, let me just say that a circuit is something where we direct electricity either from a battery or from a generator, and we send it through and we do some work on it. And when you draw a circuit, which you're going to be asked to do, I'm going to put these over here actually. There are a number of different things that you should know. If we want something to be a conductor, we just used a line. You could have bends in the line, but it just means electricity is going to flow through that. So this is a conductor. By the way, this is in your book. You'll see this in there. There's a switch. And as you can see, when it's up, the conductor has a break in it. When it's closed, you would have your conductor flowing. A capacitor looks like this, should make sense. Two parallel plates. A battery, interestingly enough, looks like this. And by the way, you can go more. You can do as many of these as you want. The bigger it is, usually the bigger the battery. This is the positive plate and negative plate. And like we talked about, a voltaic stack, you have several of those joined together. This one's important. This is a resistor. Kind of interesting the way that's drawn. Makes it hard for the electricity to go through there. And then a light bulb would look like this, kind of a resistor inside of a piece of glass. So this is a bulb. And a generator, I draw a generator this way because a generator makes a sine wave usually. Your book does it this way. And that's kind of it, except that we have two tools for measuring electricity. And the first one is called a voltmeter, and it looks like that. And the other one's an ammeter. It's ammeter, A-M-M-E-T-E-R, but it really is an amp meter. It measures amperage. So let me show you a very, very simple circuit. If I said I want a 6-volt circuit, I want a circuit, I want to draw a circuit with a 10 ohm resistor and a 12 volt battery. The way we would draw it is like this. It's actually very simple. We would put our battery and we'd mark that as 12 volts. And then we'd come over and we would put a resistor and we would mark this. I mark it R1 would be 10 ohms. And then what's interesting is once you have that, they can start asking you questions. What's the current through this resistor? Well, current is V over R. So it's 12 volts divided by 10 ohms. It would be 1.2 amps. What is the power output of this circuit? Power is voltage times current. So it would be 12 volts times 1.2 amps, or 114.4 watts. And then they could ask you about energy of the circuit, or they could ask you about any part of that. They could ask you how much energy if it runs for 10 seconds. So energy is power times time. What if this ran for, let's say, a minute? then power would be 14.4 watts times 60 seconds, and 14.4 times 60 is 864 joules, and so on. Now, that's pretty simple. You actually are going to have some problems in the book where they're going to ask you to draw these. There is one other thing, though, that I want to mention. It's this very, very short little section, going to be a short video, and then some review problems on here. But if we want to test the voltage on something, the way you test voltage is to put the voltmeter across whatever it is you're measuring the voltage. So if I said, what is the voltage across here, from here to here? We would actually take, that means we're connecting. I forgot to mention that. If you see something like this or something like this, those wires are connected together. So we're going to connect this. We put the voltmeter here and we go across here. And this, we say, measures the voltage across this resistor. Now, it's hard to explain why it's going to happen. They actually introduced this before you can understand what the voltmeter is doing. But if I did that, this would read the same as 12 volts. By the way, I want you to look at something. If I had taken and moved this dot, just stay with me as I do this. Let's move this dot and put it all the way over here. And this dot and put it all the way over here. I really haven't done any difference. That was a conductor. This would be 12 volts. But now let me take that one step further. Let me take and move this. I'm just going to flip it over and bring it over here. In other words, picture me flipping this around. And really, it's the same thing as if I had my voltmeter across from here to here. Those two would be the same thing. I don't know if you can see that or not, but basically, if I just pulled this out and wrapped it over, it would be the same thing. So a voltmeter, we say we put it in parallel. We put it alongside of whatever. We actually can test voltage simply by probing. We don't have to break our circuit. So if you had bare wires right here, and I just touch my voltmeter, and usually a voltmeter has a little thing like that that goes on there, and I have my voltmeter, this would get plugged in. This would read 12 volts on there. An ammeter is different. An ammeter, when I want to measure the current, we actually have to break the circuit. And we put the ammeter in here. And that ammeter will tell me how much current is flowing through it. It's actually not too hard to understand if you think about it like water. With water, the drop is the voltage, but the amount of current that's flowing is the same as current with electricity. If I wanted to measure how much current was flowing through a pipe, I couldn't do it by just touching the pipe. I'd actually have to put something inside that would measure it. And that's what's happening. The ammeter sends current through the ammeter, and then it tells me how much is flowing. And what they do is put a little tiny resistor in there so that it hardly affects the circuit at all. So that is that. What I would like you to try on here in the book would be practice problems. Did I write those down? Practice problems 12 through 15. Now I know there's two of them you won't have the answers to, but we can look at those later. And then problems 61 through 73 at the back of the book. And let me give you the answers for those. 61A is 18 watts. 61B is 1.6 times 10 to the 4 joules. 63A is 3 amps. B is 20, I think it's 27 volts, could be 22, can't read my writing, 81 watts, and D is 2.9 times 10 to the 5 joules. 65 is 960 watts. 67 is 60 watts for A, and B is 18,000 joules. 69 is 19 amps. 71 is 24 volts, and 73 is 120 volts. So go ahead and try those problems. And with that, we'll stop this. And all right, and that will be put up on next week's instructions.